So, we're discussing systems of equations, and in the previous video, we discussed the substitution method and the addition method. And now we're going to take a look at the graphing method. So this is an online graphing software. It's called Desmos. You can use a graphing calculator, or you can use this. And so this is another method in order to solve equations. Now, the systems of equations. So right now I am putting in the equation. Now, if you're using a TI-84, TI-83, you'll have to solve the equation for y. Our system, let me remind you of what our system was. Let me pull over the whiteboard. This was the system that we're looking at. The 2x minus 3y is equal to -4, and the 2x plus y is equal to 4. And so I'm putting in the first one, and it will automatically graph it. And then I'm going to hit enter, and it'll give me a new line, and then I'll put in the second one. So on the calculator, you have to solve it for y, because it's y equals, and then you put in the right side of the equation. On here, you can put it in as you see. And then it gives you the solution, and the solution here, if we take a look, is what we found. It's where the two lines intersect. And that, if I read that ordered pair, it would be 1 on the x and 2 on the y. So the solution here for both of these is 1, 2. On the calculator, you would take a look, you would hit second and then graph, and that would produce the table, and you could look at where the two ordered pairs match. And there's also, if you hit second trace, there's a calculate menu on the TI-80, 384, and you would go down to intersect and then select the two lines and the guess, and then it will give you the intersection point. So when you go to graph it, the intersection point is the solution. So let's talk more about that. So let's go here, and we're going to give ourselves some new space here, and we're going to say, all right, when I want to solve it, another method is to graph it. And so what you'll do, so to solve by graphing, you graph the first equation, you graph the second equation, and then you find your intersection point. The intersection point is the solution. And so you can check it, last step, check it in both equations. So that's how to solve by graphing. Now, if you graph it, and let's say you graph the two equations, and they do not intersect. Is that possible? And it looks like this. And even if I continued these out further than what I see on my paper, they still don't intersect each other. That can happen, and when that happens, that is considered no solution. And no solution means that you have an inconsistent system. So it is possible that you graph it and this happens. And so we're going to say that when this happens, there is no solution. And what you have is entitled parallel lines. Parallel lines never intersect, and this is an inconsistent solution, inconsistent system. We've already seen that it's possible that when you graph the two lines, they intersect at a spot, and that spot where they intersect is considered the solution. And so we're going to add that to our chart here. And we're going to say that there is exactly one solution. And so this we called a consistent system. And the third possibility that can happen is that you graph the lines here's one line, and here's the other line, and the two lines are the same. And so if that happens, so we say that the lines coincide. That means that they're the same lines. They just lay on top of each other. The answer here would be infinitely many solutions. So you can tell the difference by looking at the graphs. But what about when we do substitution or we do addition method? What happens when I should choose this answer? And what happens when I should choose infinitely many solutions? What happens in those? So let's take a look. So when I have exactly one solution, you will end up with x equals a number, and then y equals a number, and then you're set. You have your solution. You can write it as your ordered pair, x comma y. So we have seen this already if you watch the prior video. But what about if I do the addition method or do the substitution method? What ends up happening is that I end up with this. I end up with a false statement. And when I end up with a false statement, that means you'll have an equal sign, but the two sides are not equal. When you end up with a false statement, you're going to say no solution. And on the other hand, it's possible that you don't end up with x equals a number, y equals a number, and you don't end up with a false statement, but you end up with a true statement. Maybe it says 0 equals 0, 4 equals 4. That's a true statement. If that's the case, then you're going to answer that there's infinitely many solutions. And let's take an example, a quick example of this. Let's say that we had this problem. And I was doing this problem, and I want to take a look at this, and I see that I want to use the addition method, because what I could do here is if I multiplied this first equation by 2, then I would have opposite coefficients on the x's. So multiplying it by 2 would give me 10x minus 4y is equal to 8. And then on the second one, I don't have to change anything. And so I get this. And then I add the two together. The x's eliminate. Well, actually, the x's and the y's eliminate. So I end up with 0 here. And on the other side, I end up with 15. 8 plus 7 is 15. Well, 0 is not equal to 15. And so that is a false statement. And when I get a false statement, I'm going to say that's no solution. And we would see that if we went back to Desmos, well, let's do that. If I go back to my graphing calculator or Desmos, I am going to see that the two equations, when I graph them, they're parallel lines. And so let's clear out what we have here. And let's put in the two that we have. 5x minus 2y is equal to 4. And negative 10x plus 4y is equal to 7. And so when you graph them, take a look, we've got, even if I zoom out further, I still see that they never intersect, they're parallel to each other. So that is an example of a no solution parallel lines. When you're going to see that if this happens, you're going to end up with a true statement. So maybe it would say 0 is equal to 0. And that would be infinitely many. So let's take a look at a problem where we're going to see this in an application. So here it says 2 mechanics worked on a car. The first mechanic charged $85 per hour, and the second mechanic charged $115 per hour. The mechanics worked for a combined total of 25 hours, and together they charged a total of $2,275. How long did each mechanic work? So the question that we're asked here is to figure out how long. We're interested in the time that each mechanic worked. We know total, they worked for a total of 25 hours, but I want to know how long each one worked separately. So we're going to let's use two variables. Sometimes I like to use like the letter of the first word, like the first letter of the word. Both of these are mechanic 1, mechanic 2. So we're just going to say, let's just say x, let x equal the number of hours mechanic 1 worked. And I'm going to say let y equal the number of hours mechanic 2 worked. And so I know total, I could write, now I need to set up my system. I need to write the equation. I know total, they worked 25 hours. So x plus y has to equal 25. So I've got one equation. Now, when you are charged per hour, what you have to do is take the number of hours and you multiply it by the amount per hour. And so if I take 85 and multiply it by the number of hours that mechanic 1 worked, and I take 115 and I multiply it by the number of hours mechanic 2 worked, add them together and it will give me the total that I paid. And so now I have my system. So here's my system, and I can use any of the methods that we discussed. I can use substitution here. I do have coefficients of 1, so that would work. I can use addition method, and I could also graph the two and see where the two lines intersect. So let's say that we decided to use the substitution method. So I'm going to solve for 1, and there's various ways you could do this. Let's say that I decided to solve for the x here. And so I'm going to rewrite this equation. I'm going to solve it for x by subtracting y from both sides. So I have 25 minus y. Then I take that, and I'm going to take this expression, and I substitute it into the other equation in place of x. So I'm going to say 85 times this expression for x plus 115y is equal to 2,275. And in place of x, I have to put in 25 minus y. That's the expression for x. And now I have one variable and I can solve for it. So I'm going to distribute out this 85. And so 85, I'm going to do this on my calculator. 85 times 25 gives me 2,125 minus 85y plus 115y equals 2,275. So combining like terms, solving this. So these are my steps here. I get mechanic 2 worked 5 hours. And now I'm going to take that into the original equation and find out how many hours mechanic 1 worked. One of my original equations was x plus y equals 25. So when I put in 5 for y, I'm going to get solve for x by subtracting 5 from both sides. And this will be the number of hours mechanic 1 worked. And then I've solved my system. Now I could check this by plugging them both in.